So we've got two more problems, and these are word problems that you may have seen already, but the equations this time around may not be possible to solve by factoring. So the word problems in this section, just remember you've learned already how to create these equations. It's just the fact that the equation resulting out of it might not have been solvable in the past, whereas now it is, due to the brilliant quadratic formula. All right, so we've got Hudson River flows at a rate of 3 miles per hour. So this is a rate times time equals distance, or time equals distance over rate type problem. Patrol boat travels 60 miles upriver and returns a total time of 9. Now, we've also got the river flowing rate and the boat in still water rate. So remember, under rate, we're going to have two parts, right? Going there, if we're going against the river, that's going to be the still water speed minus 3. If we're going with the river, so that'll be the still water plus 3 as the rate. So that's S for still water. Patrol boat travels 60 miles upriver and returns in a total time of 9 hours. Now, the fact that they've given us a total time means that our time is being compared. So we're taking time against the river plus time with the river is going to be 9 hours. But time is based on distance over rate. So within each of these, we need distance over rate for each component. So let's say against is right here. So the rate is S minus 3. And with is S plus 3. But we also need the distance. So the distance was 60 miles upriver. So the boat goes 60 upriver and then also returns. So they're going 60 for both. 60 miles there, 60 miles back. You could make a table out of this, but here's our equation. This is a different way of approaching it. So now we've got an equation that we need to somehow solve. So let's just take a look. We need to multiply everything by the lowest common denominator, which is S minus 3, S plus 3. So here, in this one, if we do that, we'll have S plus 3 left. In this one, we'll have S minus 3 left. And here we'll have both, but what's S minus 3 times S plus 3? Well, that's the difference of squares, which is S squared minus 9. One thing I'd like to do in order to simplify the numbers here, because it's an equation, the 60, and the 9, they could be simplified a little bit so that we could maybe divide everything by 3. So that'll be 20, and 3. So you're allowed to do that if it's done to every single part. So that's 20s plus 60 plus 20s minus 60 equals 3s squared minus 27. So the 60s disappear. We've got 40s. So we've got 3s squared minus 40s minus 27 equals 0. And now we can solve this using the quadratic formula because it's in the format we desire. Negative b plus minus b squared minus 4ac over 2a. So that's 40 plus or minus root 40 squared plus 12 times 27, 1924 over 6. Now, does the square root of 1924 give us anything? No. However, you could simplify this and get exact values, but since this is an applications problem, and they're looking for speed of the boat in still water, we can approximate this. So let's find the approximation of both of these answers. 40 plus the root of 1924 over 6 is approximately 13.97. So that's actually approximately 14 miles per hour. Or, and let's see what happens when we go 40 minus root 1924 and then divided by 6. Well, we get a negative 0.6. So we have to reject the negative, and so that way we're just left with 14 miles per hour. And here's one more problem. Again, we've done problems like this. We've set them up before, but we may not have been able to solve this equation before because it was non-factorable. So this is a work problem, installing carpet in a room. It takes 4 hours for 2 of them together to install carpet. If each installer works alone, one of them could do the job in 1 hour, less time than the other. How long would it take for each carpet installer to complete the job? So let's say we had one installer and second installer. Remember, we've got rate of work times time worked is job completed. So rate of work is always 1 over the time that it would take the one worker to complete it on their own. So one of the workers could complete the job in 1 hour less time than the other. So if the one can complete it in X hours, the other one would be X minus 1. So if they both work together for 4 hours, then the whole job will be complete. So that's going to be 4 over X minus 1. The addition of both of their jobs will be equal to 1 full job. So again, we need to multiply through by the LCM. The LCM was X times X minus 1. So if we multiply that here, we'll have 4x minus 1 left, and here we'll have 4x left, and here we'll have x times x minus 1. So that's 4x minus 4 plus 4x equals x squared minus x. Let's get everything to one side. This is 8x, so that'll be x squared minus 1 minus 8 will be minus 9x, and then the 4 will be plus 4. And this is non-factorable, but we can use the formula because it helps us find answers to non-factorable equations. So approximately we have 9 plus root 65 over 2, which is 8.53, or 9 minus root 65, and then over 2, which will be 0.47. So it does not make sense for them to both be able to complete the job in much less time than if they work together. So it makes more sense that 8.53 hours would be the time that it takes one worker, and the other worker would be one less than that, 7.53 hours.